Okay, I think we're ready to start the session. Good morning, everybody. It is now bang on 10 o'clock in the morning, South African time. My name is Mimi Seifert-Weert. I'm from Stellenbosch University in South Africa, and I would like to welcome everybody to this session. You are in the first 24/7 session of this conference. In this session, we are going to have 7 presentations. Each one will be 7 minutes long, showing 24 slides, and we're very much looking forward for our presenters to enlighten us. Catherine, you can just put up the sponsor slide, please. Once again, we would just like, from the bottom of our hearts, to thank our sponsors, which you can see on the screen there. Without their contributions, this would not have been possible. So I'm going to introduce our first speakers, and I'm going to ask you guys to please keep to the time. I will remind you when your 7 minutes is up. So first up, we have a presentation called Context is as Important as Content, the Bridge of Knowledge platform as a comprehensive ecosystem for research information. And this is by Piotr Krajewski and Alexander Brzezinski, librarian and data steward respectively from Dansk University of Technology in Poland. And they will be speaking on how this platform fulfills linked open data requirements. Thank you.
Thank you. I will share my screen now. Okay. Okay. Sorry. So hi, my name is Piotr or Peter, if you want. I work as a librarian at Dansk University of Technology, and I'd like to tell you a few words about our portal, Most Wiedzy, which can be translated into the Bridge of Knowledge. Our history started in 2017 when the portal was launched, and it is based on the software created by our IT department. So from the one side, we have full control over the system, but from the other side, all problems are ours. And only ours. There are no ready-to-use solutions. So this is the main page of our portal. In the beginning, the group of active users was limited only to the Gdańsk Tech employees because the main source of the information was our CRIS system. So this was not natural that only our employees will be active users of our portal, but now today everyone can register and can develop his own scientific profile. So there was 10, I guess, modules then. Now is 14, and there is no time to describe them all, but they pictured the scientific output of the researchers, not only from our university. So. Okay, I already said that the most of the data at the beginning, at least, was from our CRIS system, and we have two sets of almost the same information. And what is the difference? This is the record from our quiz system. This is the record of the publication. So there is only text, plain text, and I think the DOI is actively. And next to that, we have, sorry for that, it should be moving and clicking. Next to that, we have record of the same publication from the Bridge of Knowledge. And almost every object there can be picked up, and it brings us to another module. For example, these authors, when we click in the name of the author, we're gonna see the scientific profile of this author, and so on. This is the best picture of this the web of connections between different modules can be seen in our new module that is Open Research Data Catalog. So this is the record of the metadata for research data set, and the related resources include research projects, research teams, publications connected with this data set. It's also, there is also of course keywords which can be searched in the entire platform, and this web of this semantic network brings us additional knowledge, quite different from the PIDs, because today we are very focused on giving every object PID, but we have to remember that this is not the only information we should provide. So the large context of every element of the metadata should also be considered by the repository managers, and this is the network of our connections between different objects. This is the on the left. It is the Open Research Data Repository, and to different metadata goes the information. From different modules, and
yes, I will just remind you, your 7 minutes is just up.
Okay,
you can just wrap for us, please.
I will end on that, and sorry that there was no movement in these slides. Thank you very much.
Thank you. We know 7 minutes is really a short time. Before I introduce our second presentation, I just want to mention that we're going to do questions and answers at the end of the session, and if everybody can just use the Q&A facility for that. Any questions we do not get to will be pasted onto the Google document, the shared Google document for the session. Okay, so our second presentation, is titled Helda Open Books, a repository-based service bringing out sold-out monographs and textbooks back to life. And this is by Marko Roemila and Jussi Ponen, both information specialists from Helsinki University Library in Finland. Thank you.
Thank you for the introduction. I hope the screen is now visible. Next few minutes, I will tell you about our experiences of bringing sold-out monographs and textbooks back to life with the help of our repository. And my name is Jussi, and I've written the paper together with Markku, who is in the audience, I hope, so he can maybe join in with if there are some questions later on. So, what we are talking about, the topic is Helda Open Books, a service called Helda Open Books. And we make monographs written by University of Helsinki researchers available in our repository, in a particular community in our repository. And we have well over 100 monographs available online. But the presentation now focuses on out-of-print textbooks, which we are also publishing, which is kind of a sub-project under this Helda Open Books heading. And this case of textbooks highlights some key challenges we have faced, and it has proven to be an interesting learning experience. I will tell you about it in a minute. So, very briefly about our repository. It's been up and running for several years and quite well known in the university. And we have, of course, traditional repository-based services available in Helda, and now also Helda Open Books, which has been given a prominent place in the front page. So we are really hoping to get visible with this service and to market this service now. Some key features of our service of publishing monographs. We publish them with a Creative Commons license. We use altmetric tools to track usage, and we assign DOIs to the monographs. And we also promote each new publication in the social media channels. And I should really point out that many types of expertise is needed for this kind of service to keep it running. So thank you to Markku and Soile and Mario and Juuso and Samu and all other people who are behind the service. So now to textbooks. This, as I mentioned, a kind of like a separate small project under this Helda Open Books umbrella. And this project was launched last autumn. And we started with exploiting the expertise of our colleagues in the library. We asked them to name out-of-print textbooks by University of Helsinki researchers, kind of textbooks that could be useful for students. And the result was a short list of books in the various fields represented in our university. And with this short list, we went on to find out if open access publication with a Creative Commons license would be possible with the suggested books. And this has proven to be an important and quite time-consuming part of the service. And this is because the acceptance of this license and the open access publication is needed from all the contributors behind every monograph, and also of all the contents. So this requires some finding out and some work. And we have faced some challenges in finding out if books can be published this way. And with the number of books in the shortlist, we couldn't get a permission to make a book openly available under Creative Commons license. And for a number of reasons, this happened. Communications issues with authors and publishers. We didn't get contact or lost contact. Some books were not out of print after all, and the publishers wanted to keep on selling them. Tracking publishing rights was difficult. And we also had some modest funding to acquire publishing rights from publishers. but we ran out of the funding at some point, so that prevented publishing of some books. But with those books that we could proceed with publishing, there were some further issues, this time technical issues related to these textbooks. The original print file was seldom available, so most books had to be digitized from library copies, which were actually quite worn out in some cases, so that was interesting. So there were with the digitizing, there were some text recognition problems and questions of usability and accessibility we had to face and deal with. But there are some successful examples, and this is a particularly nice one. It's a very well-known sociology textbook in Finland, a classic actually, I should say, out of print and used by the students still. And we managed to get a digitized copy in the repository. But this example highlights the issues I described, because we didn't get a permission to use the cover, but the actual text is free to use and download. And we are now seeing some activity and some download activity and altmetrics activity also. Okay, the overall results of this small project, 25% or 30% or so is now openly available. But really, it has been a learning experience, and the lesson learned is this unexpected obstacles and technical issues we have had to deal with. Good to know when we go on with the new project, which is planned for later this year. It has been successful enough for us to plan a new project, maybe with some new ideas to develop the service. And this is really material that is used by the students, so it's worthwhile. And to conclude with some positive thoughts or some ideas that this project has brought up, it's kind of dialogue between the repository as a whole and this kind of a smaller project inside, or smaller service inside the repository. We feel that the visibility of overall visibility of Helda has supported the service well. The authors usually know Helda, and the readers should be able to find the material, especially now that the material is also harvested to our library system in a better way. Also, this kind of project contributes to the development of the repository as a whole, we feel. It highlights certain issues I already described, and even issues that have been present for a long time. We now understand the role of metadata, for example, much better, and licenses and agreements and that kind of things. And we can go on developing our service in a better way.
Thank
the whole
you.
overall service. Okay, I'll finish in a minute.
Yes, thank you.
And this service has brought new audience, new types of material, and new authors to Helda. Welcome development. And finally, stimulated discussion in the library about new services and new types of material we could offer in our repository. Thank you very much.
Thank you very much. Wonderful if you can make textbooks freely available to students. I'm sure that's much appreciated. Okay, going on to our third presentation. It is called 8 terabytes of music to explore with DSpace, GLAM and IIIF, the digital library of the Milan Conservatory. I've got a list of names associated with this presentation: Marta Kripa, Claudia Cortesi, Emilia Groppa, Andrea Bolini, Riccardo Fazio, Francisco Sconamilio, and they are respectively from For Science Italy and the Conservatorio G. Verdi di Milano in Italy. I'm not sure who's going to present, but please begin. Thanks.
Okay, thank you very much. Let me share the screen. Okay, I hope you can see my screen. So let's start talking about the Conservatory Digital Library. So, as probably many of you already know, the musical cultural heritage has a strong relational nature, even more than other cultural heritage domain. Not only indeed it is possible to relate a composition to people, events, places at different levels, but for the same composition, we can have, for instance, the autograph manuscript, an handwritten theater score, a reduction for voice and piano, a libretto, a transcription for piano solo, that have to be analyzed together and take in account all their relationships. In a context like this, obviously the digitization of the documents is a fundamental step towards enhancing these relationships and highlighting other and new ones, structuring new paths and proposing comparisons between the digitized sources. With these aims in mind, the Giuseppe Verdi Conservatory of Music in Milan, since 2007, creates its digital library. And this digital library migrated in 2019 to DSpace GLAM, the digital library, the open source digital library management system built on top of DSpace and DSpace Chris. And so today, by means of DSpace GLAM, you can view, download, and reuse up to 8 terabytes of digital images, thanks also to the IIIF framework implemented within the platform. Since the first release of DSpace GLAM, indeed, you can integrate with the platform a IIIF add-on which fully implements the IIIF framework with the image, search, and presentation APIs. And since the very beginning of DSpace GLAM, the image viewer is based on Universal Viewer and provides an engaging navigation environment where the users are able to interact with images, analyzing even details that are not visible with the naked eye. And if structural metadata are provided, you can navigate the documents browsing the different parts of each one. But in the last months, we promoted a more effective use of IIIF within DSpace GLAM. Because, as probably most of you know, the IIIF protocols, it's not only for visualizing and navigating images, but it also promotes interoperability with other libraries adopting the same IIIF standards all over the world. For example, by means of the manifest file provided by IIIF, the manifest file is a JSON file which describes the structure of the document. And so sharing this manifest file, it is possible to visualize images from other IIIF compliant libraries to compare different documents. So we integrate within the IIIF image viewer another viewer, Mirador 3. So now the Conservatory Digital Library users are able to choose which viewer has to be used for visualizing the document. Here you can see then when you open the images of the document, you can choose which image viewer you are going to use. And so in particular, using Mirador, the users can import on their desktops the images both from the conservatory library itself to compare, for example, 2 or 3 or 4 documents belonging to the same digital library, but also they can import digital documents from other libraries using the same IIIF protocol. And what is important to highlight is that the whole process takes place within DSpace without the need to manually edit the JSON files or to copy images to other systems. So this is, in this way, the Conservatory of Milan is providing to their research an innovative way of doing research and an extraordinary support, for example, in the editing of criticalization of musical composition. And this further implementation makes DSpace GLAM more and more an effective platform also for research purposes, which was one of the aim when DSpace GLAM was conceived, to create a digital library not only for visualizing and managing digital materials, but to create a digital library that was also a research tool. And here you can see how a document comparison within Mirador 3 looks like, with the two documents that can be analyzed together. And as I said, you can also import and add other documents on your virtual desktop to compare them. And this is only the beginning, because conservatory researchers are still working to extend the DSpace GLAM data model, both in terms of entities and attributes, in order to make it more and more suitable for managing and describing musical documents and their relationships. So in this way, the researchers will be able to analyze more and more thoroughly all the components of which they call a real cultural galaxy, made of different types of musical bibliographic resources, linked and makes explorable by means of their relationships. Thank you very much.
Thank you very much, and thank you for keeping to your time perfectly. Really like the idea of a cultural galaxy. Thank you. Next up is Jennifer Sanchez-Davies from JISC. She will be talking about Open Doors Repository Assessment Service. Thank you.
Okay, hi everyone. I'll just share my screen. Okay, you should be able to see that. Just wave if you can't. Okay, so I am Jenny Sanchez-Davies and I work at JISC. Here I'm a service coordinator and I'm responsible for our directory of open access repositories, Open Door. Okay, so our global directory Open Door provides a trusted single point of entry to the repository community, be it through its public-facing listings or its facilitation of open access research output harvesting by global open access aggregators such as Core. We currently hold just over 5,600 repository records as well. Open Door's mission is to represent the repository community fairly and widely. And by offering support and a community base, we want to aid repositories in building high standards and broadening their impact. And the new feature that I'm going to take you through shortly works towards just that. Now, led by Coalition S, a consortium of research agencies and funders, Plan S is an initiative for open access publishing, which aims to speed up the transition towards open access. With effect from 2021, so this year, all scholarly publications that are the result of publicly funded research must be published in open access journals, on open access platforms, or made immediately available through open access repositories without embargo. Now, as we all know that repositories are a key facilitator for open research and the requirements of open research, the requirements that are put forward by Plan S, they serve to ensure repositories work towards excellent standards to positively represent the research that they hold. As such, Plan S have listed 6 specific repository requirements that strive towards good practice. So this month, we're going to be launching the beta of our new self-assessment feature for repository managers. And this will let them see how their repository fares against those 6 Plan S requirements. Following prototype demonstrations with institutions and interviews to seek their feedback, we finalized the design and the actual purpose of this new feature. So it's been through several iterations. So what I'm going to show you next is the final prototype. So users will navigate to the tool on the Open Door website. Now you can see from the orange button at the top there that repository staff will each have their own account for their repository or repositories, where they can then go in and take unlimited self-assessments to see how their repository fares against the Plan S requirements. Now, the first thing that the user will see when they're logged in is their dashboard. So by having their own account, each user can revisit their assessments and track their progress over time, rather than having to start from scratch every time. So when a user wants to begin a new repository assessment, they click on the Start Assessment button at the top, where they then have to answer a series of questions relating to those 6 requirements. Now in the dashboard, users can also expand the assessment summaries to get a quick overview of which criteria that they have or they haven't met. And they can then quickly navigate to the relevant part of the assessment, as you can see with the little buttons that say View. So let's take a look at an assessment now. So each page of the assessment is dedicated to one of the 6 Plan S requirements to ensure clarity to the users. Each question is accompanied with an information icon, which will provide them with details about what that requirement means. Now, our goal throughout this whole project has been to create an educational and informative resource. Now, some Plan S requirements have multiple elements within them. So for these, we've split them into separate sections to give repository managers a more informative overview of which specific areas of a requirement they require support. Now, in terms of the answers, you'll see here that we haven't just included a yes/no answer to the questions. So by giving more choices with the implement in progress answer, we can get a more nuanced view of repositories' current status, and it makes it fairer for repositories all round. I'm not going to go through all the questions one by one, but I hope what I've shown you gives you an idea of the assessment itself. Now, when users complete the assessment, they are taken to the results page, which have a traffic light donut chart to clearly distinguish which areas they've met, which areas they haven't met, and which are in the process of being implemented. Now, this method of scoring was deemed the most neutral amongst our interviewees. Now, if you scroll down on the results page, users are also offered clear explanations for each of the 6 requirements and guidance on how to fulfill them, as well as good practice tips. Users are also able to download a personalized timestamp PDF of the results for their own records. Now, at a later date, we're going to begin consolidating and anonymizing the results and publishing them on Open Door. This is going to allow users to see how other repositories in their country are performing against the requirements. And then finally, what we think is important about this new feature is that it supports an iterative process of repository improvement, as opposed to just being a single-use tool. The guidance that's provided throughout acts as a structured path, and it builds good standards and promotes ideal states. And overall, this helps repository administrators to understand, share, and apply best practice. There we go. Thank you for listening.
Thank you very much, Jenny, and also thank you for keeping to your time very well. Next presenter is also from JISC. So I'd like to welcome Karen Jackson, Product Manager, Open Research Services, who's going to talk about Sherpa services and global collaboration. Thank you.
Hi, thank you. Let me just share my screen too. I hope this works. Okay, there we go. Hopefully you can see my slides now. Okay, thank you very much. Hi, everyone. My name's Karen. I am the product manager for Sherpa Services, also in the Open Research Services team at JISC. And over the next few minutes, I would just like to talk a little bit about some of the work that we're doing internationally with Sherpa Romeo, and particularly on some international collaborations that we're doing. If I can get my slides to move forward. There we go. Okay, so I will cover a brief overview and some context on Sherpa's international reach at present, a summary of 2 of the collaboration projects that we're currently involved in, and also a little look at the benefits and reasons for working like this. So briefly, what we're doing and why we're doing it. So this is the summary of this session, and I've just highlighted the key terms there that the Sherpa Services team are working to enhance, increase, and improve the coverage and accuracy of our data at an international level. And we found really that the best way to do this is to engage with and work with the local experts. So the people who are experts on the local OA and policy landscape, the people that have the contacts with the local publishers, and very importantly, the people who are experts in the language as well. As these are areas that it's very difficult for us to replicate within our team in Sherpa Romeo. To set the context of where Sherpa is at present, so this is a chart taken from the statistics page on JISC's Sherpa Romeo site. As you can see, this shows the number of publishers by country that are currently represented and listed in Sherpa Romeo. So at present, the majority of our publisher records are from the USA or from the UK. We do have global representation, but the numbers decrease quite significantly as you go down the chart, obviously. One that's worth noting is that France currently sits around the middle of this chart. It currently has 88 publishers. And you'll see in the next few slides that's relevant to some of the work that we're doing. This is a chart from Google Analytics, which shows the visitors and users of Sherpa Romeo over the last 30 days. And this is up to date as of 2 days ago. And as you can see, the countries shown in blue are the places that we've had visitors from. And we have a global user base and a global audience for Sherpa Romeo. Quite significantly, France, as you can see on the list on the right-hand side, France is actually at the top of the list for users over the last month, and quite significantly so, with over 15,000 users in that time. So it's really important that the data that's recorded and shared within Sherpa Romeo reflects the global user base that we have. So in terms of the collaborations that we're currently working on, I'm going to talk about 2 of them today. The first one is with the Canadian Association of Research Libraries. Now, they launched their project towards the end of last year in Open Access Week of 2020 on creating more visibility for Canadian journals' self-archiving policies. And they were inviting Canadian publishers to submit to them their self-archiving policies. And what we've done with Carl is we've worked with them to provide them with their own sandbox version, so to speak, of Sherpa Romeo. So this is their own offline clone of the administrative backend of Sherpa Romeo. And we've worked very closely with them to provide support and training on how to use the system, how to update and create records, and also how to interpret the policies that they receive. So they've been able to create in that system a number of new records, all surrounding Canadian publishers and Canadian publications. Where we're up to at present is that first stage of the work has been completed. We've now received the data and we're just carrying out our normal spot checks And then shortly we'll be importing this data into Sherpa Romeo and making it live in our database. So at present, that stands at around 48 additional Canadian publishers and 113 additional publications, in addition to the fact that they've been able to review and update those that were already listed in the system. The second project that we're currently involved with is working with the Mirabel network in France. So this is a network run by library and information professionals in France, and they're working to basically build a system to be able to share open access policies from French publishers. And I can translate the announcement that I've shared on the page there, which is thanks to funding from the National Plan for Open Science, Mirabel will list and disseminate the publication policies of French scientific journals in order to contribute to their international visibility. And we're working with them in a slightly different manner. Rather than giving them a clone offline version of Sherpa Romeo, we're working with them to work with their database that they're creating, which is based on the Sherpa Romeo data model, and to be able to link up those databases via an API so that we can pull in that French data and make it visible and useful to our users and our global audience through Sherpa Romeo. The reasons that we're doing this on a more general level are really the broader geographical coverage and representation within Romeo records for our users, the higher quality records, as I touched on the reasons for working with the local experts, increased efficiency and support from the Sherpa team by being able to share the responsibility for collecting and processing that data, and also by working alongside these projects that are being run at local levels, they provide a lot of support and encouragement and engagement, particularly for smaller independent publishers in being able to create their own standard open access and self-archiving policies. I'm conscious that I'm just about at the end of my time, so I will show, this is my last slide. Thanks. Thank you very much.
Okay, thank you, Karen.
Thank you.
Okay, so we've got 2 more to go. The next presentation is titled Publications Router, Populating Repositories Automatically. And this is by Steve Byford, Adam Ryan, Andrea Bellini, Luigi Pasquarelli, and Susanna Mornati. Thank you very much. You guys can go ahead.
Okay, hopefully you can see my slides. This presentation, well, first of all, my name's Steve Byford. I'm from JISC in the UK, and this presentation is about a service in the UK that delivers articles into repositories automatically. It's called JISC Publications Router. Our presentation will be in 2 parts. First, I'm going to talk about how the router service works and the range of different systems used by institutions that it can work with. And then I'm going to hand over to Susanna from Forscience, and she's going to cover the new patch that they've developed in collaboration with us to enable Router to populate the wider REOX metadata fields in recent versions of DSpace. Publications Router is one of a range of JISC open access and open research services that help institutions throughout the article life cycle. If you're a repository manager, there can be a lot of work involved in capturing your researchers' articles onto your repository. Which version can you use? Which license are you able to use? And we all have different technical needs depending on what system we use. In the UK, Publications Router addresses these challenges by substantially automating the process. It alerts institutions to their researchers' articles, depositing rich metadata into repositories, often accompanied by the full text. It also passes on licensing information at the article level. So here's how it works. We work with publishers to capture articles and metadata from them. Router analyzes the metadata, especially the author's affiliations, to match the articles to participating institutions. It then delivers the article to the relevant institutions using a method and a format tailored to the kind of system that they use. And here are those different methods in a bit more detail. On the ingest side, publishers deposit the articles via various means, notably via FTP deposit or by pushing into Router's API. In addition, Router also harvests content from other providers using their APIs. On the outbound side, Router pushes XML and files into ePrints and DSpace repositories using SWORD version 2. Other systems also integrate with Router using its API. So these are the specific systems used by institutions that Router currently works with. As I've mentioned, Router can push notifications into ePrints or DSpace repositories, and Susanna will give more detail on DSpace in just a moment. Router is directly integrated also with Haplo and Pure via its API, and pilot testing is underway with WorkTribe. There's also a workflow to symplectic elements via a repository, either DSpace or ePrints. Router currently captures content from 13 publishers and 3 other providers. All but one of the publishers on the left-hand side of the slide there and a bit over onto the right, all but one of them provide full text. And we're working with many more publishers to bring them on board. Router is currently only available in the to UK institutions that are members of JISC, but we'd love to be able to offer it more widely if a way can be found. Its technology is flexible, so it should be able to meet the needs of a range of different circumstances, but there are some significant challenges to address. We'll need to understand the needs of each of the territories concerned. What are their priorities? What open access and open research policies are they affected by? What systems do they use? To get the publishers to provide the articles, we'll need their cooperation as well. Depending on the publisher, that may not be all that straightforward. For the UK, we're linking this to the renewal deals with publishers. We'll need to look into how that might be done more widely. To scale this up, we'll need to increase Router's technical capacity and also our support and management capacity. This will all need a sustainable business model. So that all sounds quite hard. But on the other hand, there seems to be a widespread global need for something like this. And if more and more funders embrace Plan S, that may simplify the licensing challenges. So now I'll hand over to Susanna, who's going to talk about the new Reox patch for DSpace, and I'll advance the slides for you, Susanna, if you just tell me when.
Thank you very much, Steve. Hello, everybody. I'm Susanna Mornati from ForScience, this DSpace certified provider who made a patch, and I'm here to give you some small technical details about it. Next, please. Technically, Router can send notifications directly into DSpace repositories using the SWORD protocol version 2. And now there is a new patch available for DSpace repositories, both for versions, recent versions 5 and 6. And this enables to have additional functionality that is RIOX specific in the repository, allowing Router to populate the RIOX compliant metadata, as Steve told you before. Next slide, please. So there are some areas of the DSpace code base that are affected by this patch. A new RIOX metadata registry is added with a number of new fields, and a new RIOX endpoint is available in the OAI PMH interface in order to allow external harvesters to harvest the repository metadata using the RIOX compliant format. And then the SWORD version 2 ingest is improved so that it allows for RIOX compliant ingest into DSpace version 5 and 6. Next slide, please. There are some relevant features that were added to this new DSpace RIOX ref add-on. And sorry, they include the RIOX OAI PMH endpoint that has been developed in such a way that it only exposes the items that are RIOX compliant, which means that they are have all the mandatory fields present in the item. Then the OAI PMH crosswalk retrieves the ORCIDs for authors and funder IDs for funders from the DSpace Solar Authority cache. And the item submission has been updated with a new step called projects. This is also relevant. This allows the submitter to associate the submission with one or more projects. And all these projects can be also associated with a funder. There is also a ref patch contained in the RIOX, but it can be disabled if required, so you can enjoy the full RIOX functionality also if you do not need a ref patch. And if you need it, it is included. Next one. Okay, these are some links to have the patch available and documentation, full documentation about it. You can contact us at this address also for more information and support options if you need. And I would like to warmly thank JISC for this opportunity and to Open Repositories for hosting this presentation.
Thank you very much, Susanna. Thank you. Okay, so we have a few questions which we'll hopefully have the time to get to. I'm going to introduce Taylor Mudd for the last presentation. He is the lead product developer at Haplo and will be talking about compliance. Thank you.
Oh, hi everyone, I hope you can see my screen there. Yep, so I am Taylor Mudd. I'm the lead developer for the Haplo repository. We're based just out of London in the United Kingdom. And I'm going to be talking to you today about supporting researchers to comply with policies within a repository system. So there's a myriad of conflicting policies which a researcher needs their outputs to comply with these days. So funders, publishers, and research assessment exercises, such as the REF in the UK, they've all combined to create a set of rules that are both complex and continually evolving, which is obviously a problem. So I'm going to break this up into 3 distinct sections: common policies and how they overlap, the design process for the Haplo repository to support researchers through submission into complying with policies without significant administrative intervention, and then also there's some user feedback and results which we've sort of dotted throughout that we've found since our redesign. Right, so as mentioned, I'm going to break these up into funder, publisher, and researcher assessment exercises for compliance there. So first up, we've got funder policies here. These may restrict embargo length on an output, require a certain level of open access, or require a certain type of copyright license be applied to the output, sometimes depending on the open access route being followed too, and sometimes also where an item can be deposited, for example, only a named or only an institutional repository. Next up, we have publishers. These might also enforce a specific deposit location, specific persistent identifiers or PIDs be used. For example, the submitted version being linked to the published version by a DOI is a common one. And they could also enforce the publisher being acknowledged in the citation too. And finally, there's research assessment exercises, which may restrict embargo length, potentially depending on which category an output falls into within that exercise. So for example, in the UK, we have the REF, and the maximum embargo length allowed for an output varies depending on which panel the item belongs to, which is then affected by the unit of assessment as well, which can be quite confusing sometimes. These might also enforce an item to be deposited within a certain time period since acceptance. So again, with the REF, it's 3 months. And then these exercises may also require a certain metadata to be completed on an output, and we'll touch on that again a little bit later. So that ties up my quick run through some of the issues with compliance. I'm going to move on to the process we took at Haplo when designing our repository. So we worked closely with the University of Westminster, and as you can see from this graphic, the approach was careful, considered, and involved stakeholders in every part of the design. And we still follow this process now. This led to the creation of a repository system which was simple enough that researchers felt comfortable navigating and using it to deposit their research without the loss of any powerful administrative features. So one of our success criteria when designing the repository was an increase in self-submission to reduce that administrative burden on repository managers. We are happy to report this has been a great success due to some of the factors shown here. So the simple deposit process with the involvement of the stakeholders in the design of the process was key. The intuitive user interface, which is provided by the open source platform and underlying information management layers, which the repository sits on top of. These include simple forms with components designed and carefully tested with user experience in mind, and also guidance. So we only show relevant policies at appropriate points in the submission process, tailored to the particular type being deposited. So I want to dive into these factors in a little more depth. So here we've got the simple deposit process. It might not look especially simple in this diagram, but that's part of the magic. So with intuitive UI components and the considered design of the interface with the user experience in mind, we have managed to condense all of this functionality down into a 3-state workflow with all of the complex administrative functionality available alongside the actual approval process. This leads to a higher data quality within the system, as researchers tend to spend more time entering metadata, and this can lead to high discovery, which is a common institutional goal, as well as increasing the chances that the researcher will complete all of the fields required to meet any research assessment exercise requirements. Again, reducing time spent by administrative staff sending items back for revision. That's a big bonus too. You can see here, Rothamsted Research, one of our clients, have cut their processing time by 75% with a switch to a Haplo system. And next up, we've got the user interface. So the user interface is clean, simple, and elements are only displayed to users that need to see them. Checking compliance is a case of a quick glance at a UI component for the library staff. This way, the burden of compliance is split between the researcher and the library. And the researcher is guided towards meeting the conditions, but the library has the detailed information to make a necessary final decision about the record's compliance. We found that typically researchers will just comply with the policy prior to submitting for approval, which has led to a decrease in the need for any adjustment of outputs. And you can see from this screenshot here that there's a little panel at the bottom of this example output, which tells us that the item will be compliant with the REF open access policy once it's been deposited, broken down again into three open access checks that are used by the REF here in the UK. Namely the deposit, the embargo length, and the required metadata there. And you can see it says it will pass on publication because it's failed the metadata check, but it will pass as soon as accepted by any repository managers. So the guidance within the system is kept to the points where it's really necessary. So excessive guidance actually, ironically, inhibits the usability of the system. Users spend more time reading walls of text about what they should do at each step of the process rather than it just being obvious. You can see the surprise in the gain in user experience from the University of Westminster here. Yep, our careful design is clear from some of these screenshots. The actions on this page are highlighting adding an output or some impact. The main bulk of the page also shows the existing outputs in the system, making it clear to the user that those are your actions on the right-hand side, while reducing duplication of submission because you can see all of your outputs, even if a co-author has already deposited it into the repository. And finally, we've only got guidance on output types that need distinction, for example, covering that books in this repository only include published or conference volumes, and any grey literature should be a report instead, reducing the need for any administrator to get involved to fix mistyping of records. Next up, so we've got the ACU based out of Melbourne, already seeing the benefits of our approach. They've been with us for a little while now. So just to round up quickly, I'm aware I'm a bit close for time. So when deploying the Haplo repository, we learned that the compliance doesn't need to be difficult. It does require careful design. So ensuring all rules are embedded in the system to minimize the need to find and check through a complex mesh of policies to verify compliance. Evaluating the processes you're implementing from a researcher viewpoint rather than an administrative ideal. To get people to comply with something, it needs to be clear how they do it. And also finally making good use of guidance rather than just putting it in everywhere considered important. So guidance should always be a last resort. Researchers should simply be able to feel their way through the process rather than forcing them to read an article just to submit one. I'd like to thank you all for your time. That's my contact address up there if you want to get in touch, and I look forward to any questions.
Thank you very much, Taylor. Guys, we have literally 2 minutes left in the session. All of the questions have been put on the Google document and the shared document, and some of them have also already been answered. Thank you very much. So I've pasted the Q&A in there. So if I can please just ask everybody to go and have a look. There is a specific question for Susanna and for Taylor there, and also for one of the GIST presenters. I'm not sure which one now. So if I can please ask you guys to just go to the shared document and perhaps just answer those questions there. Okay, then I'm going to end the session. Thank you very much for everybody's participation, and I see there are a few more questions coming in, which I will also quickly paste to the document. And thank you very much, and enjoy the rest of the conference. Thanks.
Thank you.
And this session won't actually close. We will have another session starting here in just 1 minute, or perhaps now.
Hopefully everyone can see the slide showing that the sessions that were going on at the moment. This is the going into the developer track session 1, which will start in just a moment. Okay. I'm going to start the session now. So welcome everyone that's attending. This is the developer track session 1. We have 70 minutes in total for the session. So if each presenter can stick to about 10 minutes, it will give us a bit of time at the end for questions. If I can start by inviting, by thanking our sponsors for the conference. Without them, these things can't take part, can't happen. Oh, sorry, too far. If I stop sharing and invite Chris Gutteridge, I think is my first on my list. If Chris is there and happy to start, we'll go with him. Oh, I haven't got Chris as a panelist. Sorry.
Let me try and find him.
Sorry.
He was there.
I can go with someone else to start with, it's fine. While you try and find Chris, if Kim is available, I'll invite him to start their discussion.
I am here now, by the way.
Oh,
I think I've
okay.
got presenteriness. Will I go?
Yes, you're talking. You go, Chris. Thank you.
Okay, Dirks. Find the right screen to share. PowerPoint. Okay, can you see that? Good.
Yeah, thanks.
So my name's Christopher Gutteridge. I worked on this project with a colleague called David Pepper at the University of Southampton. And I last came to this conference, I worked it out in 2010. So it's been a while since I did much with repositories. My backstory is that I'm a repositories dinosaur. I was lead developer of ePrints for version 1.0 of ePrints, just doing the last bit of OAI, then versions 2 and 3. And then I handed over to Tim Brodie over a decade ago. So it's been a while since I've been directly involved in repositories. So at Southampton, a colleague of mine called Adam Field had this great idea of what he called micro-repositories, which is when we have a data set which has structured information. Usually it's an academic with a complicated spreadsheet, and they want to provide a better visualization, maybe as this files associated with each record. And what he did was he used ePrints to build a repository for this single data set. So instead of papers or data sets, each record was a record in the data set, and it provided the search and browse functionality, which is what you've come to expect. And we've got a bunch of these now, and as a legacy, they're a pain in the arse. I'm now research application support for my university, and I have these large ePrint systems that are a hammer to crack a nut, basically, that they provide this great functionality that people like, but at the cost of having a CGI bin Perl VM that we have to keep upgrading and fussing over, and the content is never changing. And as things get older and the academics who care about them leave, it's harder to justify keeping things on, and we're at risk of losing these services. And sometimes I fossilize them, which is to say, remove the dynamic parts and get them into an archive. But I was trying to see if we could do something better, and I came up with this idea of a pure JavaScript repository. So there's absolutely no backend. There's no need for PHP. There's no need for anything beyond something that serves files. I'm slightly lying in that we use PHP in the early stages of it to convert the academics' Excel file into a JSON file for their convenience so that they can upload via Samba to the website and we don't have to convert it for them. So I drew a nice architecture diagram, and the architecture for this is we have the academic provides some files optionally and an Excel file with their structured data in, and we provide a JSON document which describes the fields the same as you would in a repository, what the fields are they a string, are they multiple, what is the description. It doesn't have any particularly complicated features like semantic mappings at this time, and then a script converts that file and the spreadsheet into one big JSON file containing absolutely all the data you need for the repository. And then when you view it in the web page, it just appears as a single page. The Excel file looks like you'd expect. We have to explain to the academics in the music department why IDs matter and rows are not good enough, because humanities academics don't always care about database structure in the way that I do. But once we explain that they shouldn't reuse them and such things, they were straight on it. We allow them to have multiple values with semicolons separated. This is what the JSON looks like. Each field has the kind of things you'd expect in a repository configuration. I hope no one's surprised by any of this. We also then use a JavaScript library called Vue to do all the templating. So there's one big file containing all the templates to make the website, which is in fact the index.html file. All it is templates and a link to the JavaScript. And that's what the website looks like. This in our first one that we did. This is the equivalent of a landing page in ePrints or DSpace. And clicking on any of the links takes you to a search for that value set to that thing. So extremely naive. All of the URLs have fragment identifiers so that you can still deep link into a browse or deep link to a individual item. And now I'm going to stop screen sharing and start again and see if I can actually make it work. Share screen again and find the one that I just set up. I have 50 screens. There we go. Phew. Sure. So this is this is the first site we did using this, and literally there's no, when I load the page, it's going to load all the JavaScript, which takes a moment but less than a very big JPEG might. And when it's loaded, I have the list of records. I can click on a record. My web address has changed to a fragment identifier. The JavaScript will pick that up. So if I reload the page, it will use that fragment identifier to jump to that record. And if I click on a value like the publisher, it will have a fixed link at the top and it will take me to just a simple search, but one that is the equivalent of an ePrints browse view. We can, if I move everyone out of the way, excuse me, scroll you to the left, I can turn on advanced search and search all of the fields. And hopefully these should look fairly generic repository features, but there is no needed dynamic backend. And in Azure, we found that running a website with PHP costs about over £10 a month. Running a website with nothing but static content starts at 6p a month. So what we're looking at is a slightly revised version, which when the academic uploads the file via Samba, then they will actually trigger it on the fly, which will cost 10p or something. And though the costs of running these long term, even with updating when the academic changes the data, will be extremely low. And it makes it easier to justify keeping on forever, which is good. One of our end game ideas was to turn this into a single giant file and upload it into the main repository. So it's a data set which comes with its own interface, but still with the raw data. It provides a JSON and CSV download format as part of the software. This is all built into the JavaScript. And it can have additional files. So this is the one we're just working on for another one for the music department, who have big spreadsheets and don't know anything about databases. So they're good people to work with. And if I search for, this is a database of music recorded in a country house in Wales, and so it can have attached files. So it's a repository. It could have images and things embedded. This is just the template from the file. And that's it. It's not officially released as software, but I talked to my boss yesterday and he said, yeah, GPL's fine. So if anyone wants a copy to look at and play with, they can. And I think it's a slightly different take on repositories. And I think that's under 10 minutes. So
that's great. Thanks, Chris.
Nice to see you all again.
Thank you.
For these years.
If anyone has questions, feel free to put them in the Q&A and we'll try and address them all at the end of the session. That looks fascinating. I want to see more of the internals of that. Okay, next, if I can then invite Kim Shepherd from the Library Code to talk about their logical item filtering in DSpace. If Kim is ready.
Yep, I'm ready. I will share my screen now. I might have to quickly switch to, yeah.
Yeah, thanks, Kim.
Okay, thanks. Hi, everyone. I'm Kim Shepherd, and I'm presenting this work with Pascal Becker. It's some logical item filtering work that we've developed at the Library Code for DSpace. So some attributions. This work was developed by the Library Code with the support of TIB and TU Hamburg. And it was strongly inspired by the XOAI filter system developed by João Melo from Lincode. And the images used in these slides are created by Teresa Busser. So to start with, we had a use case. A client needed DOIs minted at the time of archival for just some items. Now, normally the DSpace DOI provider mints and registers DOIs for all items as they come in. So we want to exclude or filter, include or exclude some of these items, based on certain conditions. These conditions, can vary. It could be which collection the item belongs to. It could be the number of bit streams or files that are in the item. It could be the existence of certain metadata values or other pattern matches on metadata values. These conditions are going to differ from client to client, and they may change over time as well. So we wanted to make sure that we developed something that was easy to configure, and that we also wanted to make sure that our solution could be reusable across all of DSpace, not just DOI minting. Pascal realized that there was a precedent for this in the XOAI filters. So XOAI has been in DSpace since version 3, and one of its really strong features is that in its XML configuration, you can define different OAI contexts, which define metadata formats and sets for items. And each of these contexts can have optional filters applied. And these filters themselves are defined in the XML configuration. And they're basically big logical statements made up of operators and conditions that say, which items should be included or excluded in that context. They're really powerful because you can do whatever you want with logic. You can come up with really complex operations. And we wanted to sort of take this idea and make something that we could reuse anywhere in DSpace. So to do that, we came up with something that we called a logical item filter service. It's a Spring service, so we can plug it in anywhere else in DSpace really easily. And we also wanted to use configuration as much as possible so that you're not constantly rebuilding every time requirements change. And these requirements are basically defined in XML as Spring Beans. So we again use the concept of operators like your and or not logical operators and conditions, which are basically Java classes that are inspecting an item and returning true or false based on the results. We can achieve complete Boolean algebra with this kind of configuration. We can, again, we can nest any number of operators and conditions within our configuration. And yeah, we just wanted to make sure that we came up with something that wasn't just useful for our use case, but that we could reuse anywhere else. And we want to be able to change it as much as possible, just in XML configuration, and not constantly be recoding every time we want to test items for some use case in DSpace. I will now give you a little look at what that looks like. So here's our XML configuration file, and this is the particular use case we had. We've got a DOI filter that we've defined as a Spring Bean. It has an AND operator here, which contains a list of 2 statements. One of them is a NOT operator, which contains this condition, and then we have another condition below. Now notice that these conditions referred to are actually references to other beans. So this one in particular, the DC identifier URI condition, is defined down here, which takes some parameters, a field name and a regular expression. So when the item's inspected in this class here, if the field dc.identify.uri contains a value that matches this regular expression, it will return true. Because we've wrapped that in a NOT operator, we're basically excluding items that contain that DOI prefix. So that NOT operator is then ANDed with another condition which says, does this item have at least 1 bit stream? So the only items that end up with DOIs minted are items that do not contain the DOI prefix already and do have at least 1 bit stream. That's a rather simple filter compared to what you can achieve. If I scroll down a little bit, we've got, well, this is an example that we supply with the code that basically implements the open air filter that XOAI already implemented. We've got a list of statements, matching the existence of various values, acceptable types, relation identifiers, and so on. We can get even more complicated because the filters themselves are beans that we've defined. I can make this even more complex filter here, which is just a demonstration filter, but I'm able to just refer to other filters I've already defined in here. So this item would have to match, it would have to be open air compliant and be accepted by the DOI filter and any other, particular conditions that I define. To give you an example of what the condition classes themselves look like, because that's where all the real work gets done in DSpace. They all implement this get result method, which takes the parameters passed in the Spring Bean. In this case, we get a field and a regular expression. And if any values in that field match the regular expression, it will return true. So they're really quite easy classes to code as well. And we've supplied, a base number of classes that should match most conditions, but of course it's very extendable. So our implementation itself is the DOI identifier provider. It now takes a filter service property in Spring, which is just a reference to one of those filters that we've defined in our XML I showed you. We've also implemented it in a way that the filter can be skipped optionally, so an admin can force the DOI to be minted with a UI button in the edit item screen, rather than always relying on that filter to be applied. And it's applied at the mint, reserve, and register actions, so metadata updates will still always run. This has a nice side effect of reducing processing time because, items that don't need DOIs don't end up getting processed. I showed the metadata values match condition. We've got you know, many other conditions that we can use. We've got one that takes a group name and permission action and returns true if that action is allowed by the group named. So this could be used for deciding if an item is publicly accessible, if it's restricted, and if we were applying this to collections instead of items, we could do things to do with workflow permissions. We can look at the minimum and maximum number of bit streams in an item as well. You know, there's really anything you can do to inspect an item and return true or false. Some example of filters. I showed the open air filter. We showed our DOI filter. Really, you know, whatever your requirements are, you're going to be able to come up with some combination of logical statements that allow only the items to be applied to what you want. If anyone's got any new ideas, I'd love to see them in the Q&A comments. That'd be great. So where's this work happening? Well, we've got a pull request just about merged for DSpace 7, very close. And it's already in use for DSpace Chris 7 for submission validation, inclusion in Google Scholar and Altmetrics badges. And, you know, we're thinking of lots of other use cases. I'm always interested in people's ideas for new Java conditions. And I'm really interested in extending the work to work with other DSpace objects like collections, communities, bit streams. That shouldn't be too hard to enhance. You can find the work at these GitHub links. We'll share the slides. It's already merged in for DSpace Chris 7. There's a DSpace 7 PR. We've got DSpace 6 modules at the library code GitHub. And there's a DSpace 5 module, which you can contact us for. Might need just a little bit more work for integration. Yeah, thank you. Look forward to seeing any questions that are in the comments there. And I think our details are all public on the conference website as well.
That's great. Thanks, Kim. Excuse me. Okay, next, if Taylor's in a place to start, and I'll invite Taylor to talk to us from Haplo about 2 features and 10 lines of code.
Oh, yeah, I'm happy to do that. Mine is quite a bit of, it's just a recording because there was a lot of, well, room for things to break doing it live. So I'm hoping you can see this now.
Yeah, that's grand. Thanks, Taylor.
Great. Right. Well, I'm going to talk you through this as we go. So, yep. So, as mentioned, so I'm Taylor. I'm the lead developer for the Haplo repository. And I'm just going to run through how to add 2 features to a Haplo repository in 10 lines of code. So these are going to be a quality metric displaying on and output and a new metadata format added to our OAI PMH integration. So I've set up here, I've created this plugin, so HRES repo demo quality metric and metadata format, which can add this to the dependencies for my application that you can see in the background there. Just adding that to the depend there. And that will load that and be uploaded to the server when we then upload that. So let's get started with our quality metric. So first up, we're going to create our quality check function, which is just going to check if the object's title has good in it. So we're going to lowercase there, just to normalize that. Yeah, just to normalize that for any case errors. And then we're going to start by implementing a service, which is going to write a store object below the XML cursor. This is a sort of common framework within the system. I'm going to get started by that by adding a title element and filling it with the item's title. All of our XML cursor documentation and all documentation is available online. I'll post links to that in the chat after this. And next up, we're going to open the add an output type. It's going to get the first type from the item and load the title of that type as opposed to our internal reference for it. So if it's a report, it will show report. And then a final element for our made up schema here for output quality. And it's just going to check the quality of the item and say if it's good or not good. So that's our first 5 lines there. We're going to close that up. And then next up, we're going to add a UI element. So again, we're going to start by implementing a service here. which is an action panel service. So again, this is making use of our underlying APIs. It's going to go into the HRES repository item category, so that'll add it to all repository item types inside the repository. And this is going to take the arguments of display and builder, which again are documented online. I'll post links to that in the chat. We're going to add a panel of priority 5 to the builder, which is right near the top on the side, and add an element right at the top of that panel. So this allows us to build different panels with lots of elements in for complex functionality. We're going to give this panel element a title of quality assessment, and then we're going to fill it with some output is good, output is not good text based on our quality check that we've implemented there. And then we're just going to close that out. And those are our 9 lines of code for 2 features in our repository. So next up, just to get the OAI PMH linked up, we're going to add some metadata about the service over in our service metadata file here. And we're going to start by popping in our service title for the store object below XML cursor, just so that the service metadata knows that we're talking about this specific service here. You see they're exactly the same. And we're going to start up by adding a few statements. The first of which being that this service conforms to our standard API, which is HRES write store object below XML cursor, and also that it is an OAI PMH exposed metadata format. There we are, there's that. And this lets the service registry, the underlying registry, know that we're this service can be used by OAI PMH for a metadata format, and that it writes this object as a using XML. And then finally, some metadata for the OAI integration for this service, which is the prefix being example metadata format, the schema being this made up example schema I've just popped in there, the metadata namespace, again, following the same made up schema, or example schema rather. And then finally up here, I think we've got a root element. Yeah, and that's the that's gonna be the root of our OAI PMH item for each item in our harvest there. And that's going to close out there, and that is all of the code that we need to write. So we're going to nip up to the top, I think, and save all in just a moment. And you'll see that in the terminal on the right hand side. That's just going to upload that to the server, our development server there. So if we nip over to the application, once this is finished uploading, we are waiting for changes. And this is our application here. You can see I'm acting as Ainsley Long in this, this example application here. So we're going to go through into our research outputs. And you can see we've got 2 items here. They're both of type report. You can see from the little icon there, the little star. We've got one that's got good in the title, one that doesn't. So if we go through to this one, you can see we've got our quality assessment in the user interface there. Output is not good. There's no good in the title. Nothing much we can do about that, well, besides editing the title. But if we go through into here, we can see now output is good. This is our quality assessment. And that's a nice little quality metric in the UI for all items in that repository now. Again, you can extend this to include things like if the ISSN's formatted correctly, or well, you're mandating multiple authors, or if you need multiple authors. So I'm just going to copy the identifier for that item there. That will come in use later on with the OAI PMH interface. So that's what we're going to move on to now. This is our sort of standard public interface to our repository. It's just out of the box functionality there. And you can see we're supporting OAI 2 with a base URL of dev6a103, which is my development server, and repository/OAI2. So if we nip up to the top here and OAI2, first off, we're going to list all of the metadata formats supported by our repository here. And you can see right at the bottom there, we've got example metadata format. That's our new one. That's popped in there alongside all of our other standard ones. DataCite, Dublin Core, OAI Reox, and using all of our schema and metadata namespace as in the service metadata. And then finally, we're just going to get our identifier from earlier, and we're going to get the record in our new metadata format now. So the verb get record, the identifier being that, and the metadata prefix being example metadata format. And you can see all of this, all of the outside sort of functionality, all of the headers and the record verbing, that's all provided by the API, and then we've got our example metadata format output here with our, I'll pump that up a little bit, if we've got the title, the output type, and the quality as we implemented before. So this is just sort of, the aim of this is to show that good composable, good APIs, well-designed APIs with composable plugins can really make implementing new features into a repository really, really straightforward and, well, frankly, simple. 10 lines of code, 9 lines of code rather, and we've got a full OAI, PMH metadata format exposed, and some nice little UI elements to tell us about the state of an item. That's everything I had for the day. I'll be happy to take any questions at the end, but I think I can hand over to the next presentation. Thank you all for your time.
Thanks for that, Taylor. Okay. Next up, I'm going to invite Adam Vilesmore from JISC to talk about developing the community ORCID dashboard. Assuming Adam is in the ether somewhere.
Hello, I'm here.
Hooray! Thank
Hooray! It's a joy of trying to get Google Sheets to present. 1 second, please. Al, if you'd like to do some hold music. You know?
A little song and dance in the meantime, huh?
Oh, yeah, that'd be awesome. For people who don't know, Al can do a mean jig. No? No?
I haven't had a lot of practice in the last year.
Okay, and it is now, of course, on a different screen. I love my Mac watch. This is except when I'm trying to present. I thought I had all this set up. Yeah. Okay, so I can start by saying what I'm going to talk about today is the problem that we face when we try and use the personal persistent identifier of the ORCID ID in an institutional context. So there's a tension between the, this is the bit where I try and get that screen. Come on, you can do it. There's a tension between the institutional need to have reports from all your researchers and the institutional want to have a view over everything and researchers regards for their personal private data. And at this point, I am just having a complete brain melt about presenting. There you go, that's that. Right, and then Alt Tab for Zoom, and then share. Sorry, guys. It's always the way, isn't it? That's the one, share. Right.
That works.
There you go. Sorry, everyone. Right, so basically, there you go. There's the first page. This is work that I've done together with Kirsty, UCL, Monica from JISC, and Owen Stevens, a consultant who, all of these are fantastic. Any errors and omissions and badness at presenting are clearly my own, and all the good stuff in here is clearly their responsibility. There's my Twitter handle at the bottom. Please tweet about the disaster that's ongoing. My ORCID ID, because of course I do ORCID stuff. And I also want to mention we'll be talking about the powerful chamber that we really at some point need to have a better view and name for. And that's partly because it's just currently named after the Heroku app that it runs on currently. Right, so the ORCID record as a whole, back on track, has the potential to carry on your whole career narrative. It's a great thing. I wrote a blog post when I started at JISC as someone who was part of the team running the UK ORCID consortium about the fact that, you know, it's a great thing, but a lot of the records aren't complete. They're not necessarily actually affiliated to your institution. Call it the fluffy bunny story. So, you know, instead of having an ORCID record with the affiliation University of Example, thanks Taylor, you end up with a fluffybunny@hotmail.co.uk, and that doesn't really help you with that. People have privacy settings set to only trusted identity or private themselves. However, you might have ORCID IDs for your researchers in your CRIS, in your, wait for it, repository, linking into the meeting, in your HR system. But again, they might not be complete. They might not have complete information. So what we're trying to do is think about how we optimize the flow of these ORCID IDs. It's a tautological thing, just get over it. I have to eventually. Around institutional information systems. We plug into the open sources, we potentially assert affiliation where that is missing, and we can use that to identify areas where targets for advocacy and populate those gaps. So it's partly about ensuring that institutions have a view of this incredibly important persistent identifier, and also for their researchers that they have a way of getting the information that the institution holds back into their records. Now, so when I joined JISC to support the UK consortium, okay, that's probably enough name checking of my job. One of the things that people asked a lot was, okay, so I'm a member of the ORCID consortium. I've joined now, so please tell me all the people who have ORCID IDs in my institution. And we went, well, it's not as simple as that. Sorry. So we started to look at whether or not this had been something that had been identified before. And my goodness me, yes, it was. So in the various hack days and stuff that had been run in the past few years, there had been various bits and pieces and projects. And so we wrote specifications and requirements, kind of summarized all of those things. And if you're interested in those, the last slide has a link to the wiki where we've got all of those things. And we invited a few good souls to come and review those and start to build a kind of feasibility test for a platform. And that was, gosh, some time ago. Then we brought stakeholders together. And if you've got all the people on the right-hand side of your screen, you're missing out on the outputs from that, where people were, just move people out of the way, move people out of the way. Thinking about kind of how these would work in a institutional context. So we've got ideas like orchestra. I mean, all of these are better than Corda, trust me. Scholar site. We've got the management, mining, and monitoring ID system. And we also have there, you know, this kind of idea of how these systems would be embedded in universities to give ideas to the kind of PVCRs, how they'd help institutions, help researchers and themselves. So one of the things that we were looking at was how, in the context of the information that's stored in things like repositories, we could both work with researchers and institutions to get this information together. Right. We also, I should mention, at the second workshop, built up a lot of things to try and get these connections together. What are these things, Adam? I hear you asking, because this is quite a lot of kind of, you know. Oh, there you go. Right, so what we did, and there you go, there's the first plug for the GitHub, was build links into information sources. There's an ePrints plugin. There's Haplo. I don't know, I've not heard of this system before. Oh wait, there you go. Yeah, there's a Haplo system. You can write 9 lines of code, apparently. It's really easy. There's a Samvera implication, Samvera gem that was written by Julie, and it's great. We wrote some things on zombie detection. So that was looking at kind of this idea of ORCID IDs that were around for ages but not really doing anything, and also IDs that were kind of like inactive as well. So we had a prototype, and you can see, again, fantastic. It is a dev session, so I'm easily get away with this slide, where we had ORCID IDs, testing test case data, and then where the kind of source for that information was. So we were like building reports out for how this information had come together. And then kind of, as you see, it's not quite an MVP yet, but the idea was that there are in the bazaar a way to put your ePrint system together to emit this stuff. And there's Haplo plugin. Again, Tom Renner built this originally, and you could always speak to Taylor about it. And there is a gem, and there is some other bits and pieces that we've got together, which means that you can gather all this information right now. So even, you know, if you don't want to do it for Corda, you can actually emit this information as well as just report it. But what I want to spend a couple of minutes just talking about is this idea of the affiliated records. So as a really quick win, what we thought is, while we're trying to coordinate all this stuff together, what really matters to a lot of people is, who are my researchers who have ORCID IDs? And kind of inversely, who doesn't have one, because they're kind of the people that we need to talk to. Who has 4, who are sharing one. I'll wait for about a couple of weeks and you'll see a really interesting blog post. And so we've built something that kind of looks at the way that you can detect who is currently associated with your institution. So this is in Owen's GitHub, and it, well, right. So in a brief overview, the ORCID API demands a to-call, right? So you need to build a query to say, I'd like ORCID IDs that fulfill the search criteria. It says, fabulous, here are all the ORCID IDs that fulfill your search criteria. Then you need to individually get any details for any ORCID record. What you can't do is say, I'd like the details for all of the ORCID IDs that fulfill the search criteria. So that can make doing some things with the ORCID API a bit annoying. Technically complex? Yes, let's go with technically complex. So I'll actually show you in a second. But what the powerful chamber, again, that's the name of the Heroku instance. It really needs to be called something else. Does is it does the to-call circuit by doing the search on the API, and then it's got a Node.js node fetch on the page. So the second call is actually done on the page, which is why I've got a screenshot of it rather than doing it live. In Reading, what happens is that they run that, and then they've got Excel with macros. So there's a number of different ways to download it: CSV, Excel, PDF and stuff. And they've got some macros, so they actually ran a lot of things on top of the output to identify places for advocacy and intervention. I should mention the ORCID US consortium also adopted this and did a pill of the code and adapted it. So that's why at the moment, when you look at it, again, I'll show you the instance in a second, you can see the US institutions listed first rather than UK ones. Some modification to the code is upcoming. So what's it look like? So the powerful chamber has some warnings on the fact that you know, you won't get everyone who is at your institution back, because that's not how the affiliation works.
Give you a minute, Adam.
Yep, and you can search it for those different ways, and you get all these results back, and those are different things. Right, so what we're going to do, at the moment, we're working internally to move things forward like that. We've got some technical updates going because the initial queries were on Ringgold's, and now we can do much more powerful queries. It still looks like we built it in a couple of days, so we're going to make that better. Got a funny thing where we've got a limit of 10K results, and ORCID don't know why that is either, so we're waiting to hear from that. We're working more on Corda itself to look at the kind of data lake fabric. In the wider environment, we need to look at UK PIDs for OA, and REF highlights we need more interoperability beyond ORCID. There you go. So please get in touch with us. There's a huge way to get in touch with all the different things that you need. Thank you very much.
Thanks, Adam. Okay, and then I think hopefully should be the final presentation for this morning in this session is a recorded presentation. I think if Catherine can line that up for me. It's from Yasmin Al-Saidi and Daryl Grenz from the King Abdullah University of Science and Technology in Saudi Arabia.
Okay, I can share it. Yeah, hold on a second.
Thanks.
Oops. Unless Daryl or Yasmin want to do it.
Hello, thank you for joining us today for our presentation about our institutional ORCID integration. The first part, I just want to show how our basic setup is. So we do have a DSpace that's hosted in the cloud. We like it because it's very stable and reliable, but we also would like to do more than is possible through DSpace. And so for that, we've added these local services. The one we'll talk about today is our institutional ORCID integration. The main way it works is by checking DSpace for new and modified items through the OEI service, and then updating DSpace through the REST API. And then on the other side, it's updating ORCID also through the ORCID API. So there is some support for ORCID now in DSpace 5 and 6, but it's quite minimal. And even in DSpace 7, there aren't plans to quickly change that. In DSpace Chris, there is really strong support for ORCID. However, we've decided to stay with our own ORCID integration because it has some features that we like, and it already works well for our setup. So our approach has been to make some changes to DSpace. These have been released as a patch for DSpace by Atmeyer. This allows you to have the ORCID ID icon display as a link to ORCID on an item page. And it also allows for the management of ORCID IDs through the REST API. And so that's what our tool uses to interact with the DSpace REST API and connect it to the ORCID API. It runs on a pretty standard local server, Apache, MySQL, and PHP. And now my colleague Yasmin will introduce how this works for the library staff.
So there are three main users for the IOI application. The admin user, it's the library staff. I will show you a live demo. This is the main page, the login page for the IOI application. We use the LDAP authentication. This can be done with the help of the IT department in your institution. This is the main page, and if you are an admin, it will show you. It will appear. This button will appear to your main page, and all the functionality here. It's only displayed for the admin. The first thing you have to do is uploading the file, the data, and if you want to upload it, you have to click on this tab, and it will display the form for uploading the file. You can choose the file. It's accepting only CSV. And from here, you can select what is the type of the file that you has been uploaded. And if there's any error, the system will return back the error message to you. There's only one condition here, is the person data must be uploaded before the person-organization relation. After that, you can send an emails. Each group here, you can send an email to each group individually. And here you can find the description of that group. What is this group stand for? And you can send a batch for that group or test only. Test only means that you send it to your institutional email, and this can be configured by using the code, the IOI code. Also, you can update the names in DSpace by adding the ORCID ID for the person, for the specific person, and add the correct name and update the names in the DSpace. Finally, this is the dashboard. The main thing here is show you the percentage of the registered group to ORCID using the IOI, and here it will show you the same thing but with the timeline. Returning back to the presentation, this is the screenshot of the same thing, and now Daryl will present the functionality for the students and the researchers.
So from the user perspective, these are all the things that they can do through this tool. There's actually some variation here depending on how you configure it. So we do support a couple different scenarios. For example, if you're an ORCID member or not, or if you have a DSpace repository or not, this tool can be used in those different cases, but the users will experience it a little differently. So in the main configuration file here, for example, you do need the institution abbreviation and name. This displays in the user interface. The other details, the city, country, Ringgold ID, these are really if you're an ORCID member and you want this information to send into people's ORCID records as part of the affiliation information. Then this is the DSpace setup. And here's where you would say ORCID member true and enter your client information that you get from ORCID. The redirect URI is actually the URI of this tool, of the orchid.php page of this tool. So when you send a user to ORCID, ORCID needs to know where to send them back to. And they will only send it back to an authorized list of links. And so you need to give them the link to this tool. If you're running it on a test service, it could be like a local host link. So you sent your emails, the users clicked the link, they came for the first time to the orchid.php page, they logged in with LDAP, and they see this screen to create or identify their ORCID. Because this institution is ORCID member true, so we see some options for the permissions. If it was ORCID member false, the second two permission options just wouldn't display, and the user would just have the option of identifying or creating an ORCID. But here, ORCID members, we can send information to the ORCID record, so there's more choices. Once they've gone to ORCID and they've been given the permissions and they've come back to the tool, then they're presented with the list of publications and affiliations that they can select to send to ORCID or to ignore. They deselect something, it will be ignored. And if it had an ORCID ID attached to it already, it would be removed. Or if it was in the ORCID record already, it would be removed. Then after they've done that, immediately the ORCID record will be updated with the works and affiliation information, but DSpace, actually there will be a delay before any changes show up there, because we're not running the update through the REST API immediately. We're running it as a background service because we found we have to manage how much we try to push to the DSpace REST API at once. It appears this is an issue with using the ORCID IDs because they need to be updated in the Solar Authority Index for DSpace. And so doing a lot of updates can overburden the system. So we run it as a background task rather than doing it immediately. So users don't need to wait for the DSpace part of the update. Then if the user comes back to this page in the future, this is what they will see: confirmation of their ORCID, the option to change permissions, and the option to see their history. And then from their history, they can also modify the history, modify what is connected to their ORCID. Okay, my colleague Yasmin will conclude by talking about how we also support sending information to other systems in the university.
So other university systems can benefit also from IOI apps. They can retrieve the ORCID ID or the list of works based on the person institution ID through an API. We call it Query API. By sending a GET request to this API, including the institutional ID for the person and the request, what is the request from this query. For example, here we request the ORCID ID. It will the query will return back the ORCID ID for that person, that we include the ID, his institutional ID in the query. And what is the response that you want to get back from this, the type of the response that you want to get back from this API. Also, you can send the request as requesting the works for this person. But if you send the works, you have to send the year, or you can say all to send to retrieve all the works in all the years for that person. So this is the end of the presentation. Thank you for listening and attending. We will post the IOI link in the chat below. Also, you can send your questions. We are happy to answer all the questions. And if you have any question later, you can send it via email to Daryl or me. And thank you again.
Thank you, Daryl and Yasmin. It's fascinating work. I don't think there were any questions still in the chat that haven't been answered, but if there are, somebody, if you can ping them again, or if somebody can shout at me who has a microphone, and I can address them, we can try and address them. I think that's all our presentations for this session otherwise. So if there are no more questions to be asked, I can give you back an extra 10 minutes of your day. And the next session will be in 2 hours. It's the Minute Madness, which you'll find through Shared. So other than that, thank you for attending. Thanks, Catherine.
Thanks, everyone.
Thanks. That was a great session. So that's where we are now. We're finishing up this session. I want to say again, thank you so much to all of our sponsors. It's thanks to them that we're able to do this. And thanks to the moderators, Alan and Mimi for the earlier session, and to all the attendees and all the speakers for their very interesting presentations. So yeah, we have a bit of a break in the program now, so hopefully I'll see a lot of you at some of the later sessions. Thank you very much, and we can end the session now.